and engagement in model checking courses. So Philipp, the floor is yours.
Thank you very much. So, in this talk, I'm not focusing too much on what we teach, but I'm going to talk you through a variety of ways how we taught model checking courses. And first off, I'll give you an idea of what formal methods is in our group in Düsseldorf. We teach basically 4 courses that you can consider formal methods. 2 of them are about prologue, one that teaches the basics in the bachelor, and one in the master program that sometimes also covers aspects of CTL model checking. Then there are safety critical systems where we teach event B, and basically the idea is how to write a specification, use the tools around it, use model checkers, and use provers and try to give a proven, verified specification that can be used to generate code maybe. And lastly, we have a course model checking, and this is what is the focus of this talk. And the basic idea is the student should be able to understand how a model checker works and be able to implement a model checker. So the last thing I'm going to talk about what is done is basically is principles of model checking, the first 5 chapters, and that's it. If you want to see the details, you can pick up the book. Roughly, they should know and be able to implement model checking algorithms up to LTL, sometimes CTL model checking, depending on how fast the course moves. They should be able to prove whether some properties are safety properties, liveness properties, omega regular properties. And there's also proofs that usually the students don't do, but the lecturers have to do, and everybody falls asleep as we know it. Like, why is the nested depth first search for LTL model checking correct? Um, it's a long proof. It takes an hour or so, and there's not much interaction. And that's sad. So I'm going to briefly summarize 3 of our course iterations in the past, and I'm going to focus on the one during the pandemic we held. And yeah, I'm not going too much into detail now. What we had up until 2016 was a good old lecture-based setting. So there is a lecturer that presents all the content, and more or less they copied the book on the slides and went through it, one slide after another, giving a definition, giving some proof, and the students remained unengaged entirely. And the second date in the week we had was that there's an exercise group. So they get this exercise sheet and should prepare it, rarely actually do it. Often the lecturer again has to present the solutions. And again, students remain unengaged. So we thought maybe this is not the best we can offer. So Sebastian changed a lot in the next year. In 2017, he started a rather problem-based learning approach. Like you don't have to read what's written on the cards on the board, but the idea is in the first session, he collected a set of issues with a lift. What can happen, why it may fail. And they are organized on a set of to what degree software is involved. And the idea is at the end of the term, the students should implement a model checker and try to verify that all the issues caused by software are actually cannot happen, so that we have a correct model of a lift or specification. And he gave the control of the course more or less to the students entirely. So the approach was go ahead and do research how to do it. And at the end of the of 15 weeks, they had an entire model tracker for a subset of the B language. It was published in a paper with the students or some of the students, and it worked more or less. There are many benefits. Like the students really were engaged. Like the entire thing was driven by the students in discussion sessions, in research sessions and development sessions. Sometimes they discussed what to do, what of several approaches should be done, and then went home and implemented them. And then they came back, and in one big group, they developed this model checker from scratch. And they also improved on their software development skills, on their team skills, on communication skills. And that's all good. There are some drawbacks as well. Like there's lots of boilerplate that doesn't really have to do with model checking. So they need a parser, they need a language interpreter, and for the beat language, this requires more or less to implement a constraint solver. They had a graphical user interface frontend that is nice to have for a model checker, but doesn't capture the essence of a model checker and of the algorithms. Also, Sebastian had a small group, like 7 students or so, and this is a group size you can work with as a team. And that course was too successful, I dare to say, because the next year I tried to give such a course, and I had 25 students sitting there in the seminar room, and it does not really scale to arbitrary sizes. Of course, argue you could do several groups and compete against each other, but as mentioned before, you need different sets of skills unrelated to model checking, and to have such a heterogeneous group of students in all groups is not easy. And also the knowledge doesn't propagate evenly. So if one person focused on, okay, this week I'll implement this LTL model checking algorithm, all other students don't really get the details the other has to deal with. So at the end, one person is a specialist and the others just get a rough idea of what's going on, but they don't have the intimate knowledge. So the 2 years afterwards, we didn't dare to repeat this. And we tried to reduce well, we went back to the lectures more or less. And we tried to reduce what we actually present in the lecture, like formal proofs and algorithms and their correctness. We reduced discussion of that. But instead, everyone should implement a model checker, and as part of the overall grade, should extend it to work with LTL. Provided a parser and some algorithm libraries for Bücher automation generation, for example, and chose a small formalism such as Petri nets. Such a language interpreter can be implemented in less than an hour, I dare to say, and lets them focus on again the essence of model checking. And this worked somewhat. So the students did go home and had something to do, but in the end, when we met as a group during lectures and exercises, again they were somewhat unengaged by the lecture itself, because they get new knowledge, and it's again definition and proof and all of that, but less of that. But still, we can lose their interest and very fast. And also, if you don't understand properly a definition and don't ask a question, you get lost along the way. So we were somewhat satisfied with the result, but we didn't want to repeat it, mostly because COVID hit, and we had to adapt with not enough time as everyone else. So we tried something else. we tried to invert the classroom. So our university library provides an ebook version of Principles of Model Checking. So everyone has the book, and instead of reading the book to the students, they should work through it at home. And this follows a similar overall idea of that Luca presented earlier. They should work through the material in their own pace. And especially because there are lots of mathematics involved there. They probably need an individual amount of time to really grasp it properly. And we think they could do it at home way better than following the pace of a lecture. Also, to give students something to work them through it, we used a lecture that Professor Cartoon provided. He put it on YouTube, and we just linked to his videos and said, okay, for this week, you can watch this lecture. And the online meetings we only had one meeting per week. We discussed questions the students encountered, and we solved exercises together. And of course, you may ask, how do you ensure that the students are actually prepared? I used cheap tricks, and I said everything on notes, on the algorithms, on definitions, on exercises, they hand in by a deadline they may use in the exam. And the deadline was, of course, the date of when we discussed a certain topic. So students were motivated to get it done by then, and then they could actually bring questions into the session. And we required some guidance for the students because everything is done at home. So as I mentioned, we had this deadline by when they should be finished. And this is written on a reading guide that contains all the material, like read section 5 to 8 on this in this chapter, and maybe section 10 to 12, because we don't really care of what happens in section 9. It contains the links to the lecture recordings, contains what concepts they happen to stumble up on and which of them really are important and they should know it. And also a list of learning outcomes. And I cannot stress enough, if you send students to learn at home, you have to tell them what they have to learn and what you expect of them afterwards. So they can judge themselves, am I able to do this or am I not? And further, we give them some exercises which align with the learning outcomes and that have been prepared anyway, that would have been on an exercise sheet. And in the online session, we try to engage the students more. We started with a mood barometer, just a set of emojis, and I'm not sure whether I can. So can I share the annotate function with everyone? I'm not sure. But basically, everyone is able to just point to it on the slide and can give an idea of how they are feeling, whether they are happy, whether they are stressed, what they want to do instead, or what they want to do after the lecture. Whether they want to play some video games, want to do some sports, whether they want to go on vacation. And you could just get some social embedding of the students, and that's really nice and important, especially when online teaching, because they don't see each other, but you can still communicate with them and talk to them. So this is important. I can't stress it enough. And with this, you can build some trust and engage the students initially. You can ask some questions, some multiple choice questions, use polling, And after a while, we just, so I prepared some exercises and we discussed them online. And just some random screenshot, don't mind that it's in German. Different students, different colors, and they just worked with the exercise. So here they found a counter example to this fairness assumption. And you can also see in the bottom right, there was a poll going on and they participated that way. And more or less, I just bought the exercises, they discussed it. And I didn't really have to do anything except if they got some detail wrong, I was able to correct it, to set it right, to give the correct idea. But since they were prepared and were able to deal with the task at hand, it was a fun and engaging way to have the session work out. So I'm going to finish soon, but I want to stress there are many ways which you can teach. And I think it's a very, very bad idea to become a robotic reader of something that already exists. So for us, that is Sebastian and me, teaching ourselves in the way of standing there and just showing and talking and just telling what the material is about, that's boring. And we rather want to assist students with learning themselves. And this is what we do in other courses as well, since we experimented with it during COVID. And it really works out well, and you can provide much more individual support this way. Not saying that lectures are bad or wrong, but for us, it's certainly something we prefer when teaching. So that's it. If you have any questions, I'd be happy to take them. Go ahead. Thank you.
Thanks a lot, Philipp and Sebastian, for the contribution. And I'm sure that this opens many questions for discussion. So I guess the first question is about Cliff. So you can unmute yourself.
So I started typing, but you got to me. Thank you. Very interesting. Thank you very much. Assuming COVID goes away tomorrow, which is perhaps a little bit optimistic, what will you do next academic year with the course?
If I had to give it again, I would really prefer to do an inverted classroom again. And right now, we've got some hybrid systems going on in another course. So I'm actually standing in the lecture hall, but I'm still going with an inverted classroom. It's just way more fun, I promise. And also it's less work. You don't have to prepare the material. You don't have to know the exact details. It's easier. You can hand it over to a colleague and he can teach it. Yeah.
Thank you. So there are so many questions. So Lars Søring.
Not a question, but a comment that I have for several years given a course in programming language semantics with a very similar setup from what you have. And it works very well and the students love it. So I would really encourage other teachers to attempt the same approach.
Thank you. Jose?
Well, I have the following experience. Last year, I gave my lectures online. I made videos for all of them. During lectures, I was available online for a kind of tutorial mode. And my experience is that the students have little autonomy. Very few came to the classes, actually. But I believe they were looking at the videos, otherwise all would have failed, okay? This year, the COVID situation in Portugal is not currently very, very problematic, so I'm actually lecturing in the classroom. But in the beginning of the lectures, I asked them, which mode do you want? Last year's mode or the theater that I'm going to play here, to perform here? And they said, we want the theater. Okay, so what that means for me is that it's not only the theater. They want to be together, okay? The classes for them is a social event. It's because they are, so that's a problem that we have. I'm very frustrated because it was a lot of work, as you say, but it's probably is going to be lost, okay? And not reused, which is a pity because I think that's the right way. I've invested in reverse classroom for a long time, but with very little success, I must admit.
Yeah, I
Thank
agree.
you. And thank you very much for this talk.
Okay, thank you. But the idea is, of course, it's a social event that's happening in the classroom, and there should still happen a social event in the classroom. But the students shouldn't sit at home and solve the exercises by themselves. You can just pull that in the classroom. Just sit at home, the material, and just be there for them, let them solve exercises and work with them in that way.
Yeah.
Lucas?
Yeah, I was just wondering, so you showed a slide where the students had some used the pen or something. So do they have tablets at home or?
Some of them did. When they did not have, I was the one with the tablet that wrote down some notes for them instead. It works better if they have a tablet. Yeah.
Yeah, I suppose that could be very problematic. Yeah. Thank you.
So it's important that you have a culture that allows an open mic for a small group. So one can just say what they think and have interaction that way. Who writes it down? Another student just writes it down for them. That's fine as well.
Thank you. Matthias?
Yeah, so thanks for the talk. It was interesting. I wondered in evaluation, so did the students do an evaluation of the course, and what did they say? And in particular, the written down notes, not the statistical evaluation, but the written down notes. What did you get from them, and how did that relate to last year or the year before?
There was an informal evaluation because the course size was too small for a formal one. And the students were really happy with the course. And that might be because they were very grateful because since we offered the course anyway due to despite of COVID. So I guess there's a bias because they were happy they could do something in the semester. I mean the evaluation always was kind of good since we tried something different. I don't think whether there's much difference between the year before to the year before. But what we had on the comments, it was all positive, and some people said that they wouldn't do an inverted classroom or wouldn't prefer inverted classroom if it was in non-COVID times. But due to that situation, they were really happy with how it went.
Did you get the response that it was more work to do? Because this is what I see sometimes when you do videos to prepare, then the students often have the impression it's more work that they have to do.
They did not try to. They did not. The thing is, we reduced the content of the lecture, and we also reduced the time that we spent together. There was already one session in the week instead of two, so it was less work overall.
I think what fundamentally increased students' feeling of having to work more was introducing programming. Before they had just the lecture format, and then a year later they were supposed to implement something, and they didn't measure if there were less lectures or less content. They just saw, oh, now there's an additional project. This will be more work.
And very often you have to do the same amount of work on average over the whole year, not just in the end learning. Yeah. Okay, thanks.
Great. Thanks a lot, Philipp and Sebastian, for your contribution and the great work.